Hey everyone, today we are going to solve the Daily LeetCode challenge of 25th March 2024, and the problem statement is find all duplicates in an array. So let us first understand the problem statement. So according to the problem statement, we have been given an integer array nums such that each of its elements are in the range of 1 to n. Okay, and both these 1 and n are inclusive to this range. Fine. Now according to the problem statement, each of the integers in nums appears either once or twice. And what we have to do is we have to find out all the elements in nums that are occurring twice. Okay, so let's see that which all elements in nums are occurring twice. So we can see that 4 is occurring only once. This 3 is occurring twice, right? Here is 1, 3 and here is 1, 3. So it means that we'll have this 3 in our answer. Okay. This 2 is also occurring twice. Here is 1, 2. Here is 1, 2. Okay. So we'll have 2 as well in our answer. Now this 7 is occurring once, 8 is occurring once, 1 is occurring once. So our answer would be this 3, 2. Correct. So let's see how we can solve this problem. So the first approach of solving this problem is pretty obvious, that we will be keeping track of the frequency of each of the element of nums. So what we can do is we can take a hash map and we can simply iterate over all the elements of nums. Let's say currently we are at 4. So what we'll do, we'll save 4 and we'll set its frequency to 1. Then we'll move to the next element. So we have got the 3. What we'll do, we'll save 3 and we'll set its frequency to 1. Then we'll move forward. Then we have again got a 2. So what we'll do, we'll enter 2 and its corresponding frequency as 1. We'll move forward. So we have got a 7. So we will save 7 and its corresponding frequency as 1. Now we'll move forward. So we have got a 8. So what we'll do, we'll enter an 8 and we'll set its frequency as 1. Now we'll again move forward. So we have got a 2. Now we can see that we already have a 2. So what we'll do, we'll increment its frequency from 1 to 2. Now, what we were doing is we were iterating over nums in order to populate the hash map, correct? And what we are storing in the hash map? In the hash map, we are storing the frequency of each of the element. Now, while populating this frequency, we'll add a check that if, let's say the name of the hash map is frequency. Okay. So if frequency of any elements, this I represent the current element. So if frequency of any element becomes equal to 2, in that case, what we'll do, we'll take a vector. Let's say the vector is answer. So we'll say that answer dot pushback this I, correct? So we can see that here what happened. Here the frequency of 2 became equal to 2, right? We can see that the frequency of 2 is 2. So what does it mean? It means that we'll store this 2 in our answer. So let's say this answer is our vector. So what we'll do, we'll store this 2. Fine. Now we'll move forward. So we have reached 3. So what we'll do, we can see that 3 is already present. So we can simply increment its frequency. So now we'll see that this frequency of 3 is equals to 2. So in that case, what we'll do, we'll push it in the answer. So we'll get a 3 over here. Now again, we'll move forward. Now we have reached this one. So what we'll do, we'll store this one and we'll set its frequency to 1. Now we'll move forward. Now we can see that we have completely exhausted the array nums. It means we have processed each of its value. And what is our answer? This is our answer. Fine. Now, what would be the time complexity of this solution? Since we are iterating over the nums, so the time complexity would be order of n, because we'll be iterating over each of its element. And what would be the space complexity? The space complexity would be order of n as well. Why? It's because we are creating a hash map over here, correct? So the space complexity is order of n. Now my question is, are we going to use this solution in order to solve this problem? So the answer is no. Let's see why. So here we can clearly see that in the problem statement, it's mentioned that we can use only constant extra space. But what we are doing over here we are using a space complexity of order of n. So we can't use this solution, right? So let's see how we can solve this in some other way. So since we can't use any extra space, so what we can do is you'll say that, okay, we can't use any extra space. So what we can do is we can sort this nums. So if we sort this nums, what we'll get 1, 2, 2, 3, 3, 4, 7, 8. And what we can do is we can take 2 pointers P1 and P2. Okay. First of all, what we did, we sort this nums. After that, what we are doing, we are taking 2 pointers P1 and P2. And after that, what we'll check that if this P1 equals to P2. In that case, what does it mean? It means that we are getting a number which is repeating twice, correct? So in that case, what we'll do, we'll simply add it to our answer vector. So we'll say that answer dot pushback this P2, correct? So let's represent our answer over here, which is an empty vector as of now. Now what we'll do, now we'll check that is the value present at P1 and P2 equal? So we can clearly see that the value present at P1 and P2 are not equal. So what we'll do, we'll increment both the pointers. So P1 will now point at this 2 and this P2 will now point at this 2. Now we'll check, is the value present at P1 and P2 equal? So we can see that P1 is 2 and P2 is also 2. So what does it mean? It means that their value is equal. So what we will do, we will add it to our answer, correct? So it means we will add 2 to this answer. Now what we'll do, we'll move this P1 ahead and we'll move this P2 as well. Now we'll check that is the value present at P1 and P2 equal? So they are not equal. So what we'll do, we'll move this P1 over here and we'll move this P2 over here. Now we'll check, is the value present at P1 and P2 equal? So we can clearly see that the value present at P1 and P2 are equal. So what we'll do, we'll simply push this P2 in our answer. Now we'll move both the pointers ahead. So we have P1 over here and we have P2 over here. Now we'll check, is the value present at P1 and P2 equal? So they are not equal. So what we'll do, we'll simply move both P1 and P2. Now again, we'll check, is the value present at P1 and P2 equal? They are not equal. So we'll move both the pointers. Okay. Now we'll again check, is the value present at P1 and P2 equal? So they are not equal. So we'll move both the pointers, correct? Now the moment any of our pointers points at an index that doesn't exist. So what does it mean? It means that we have successfully processed all the elements of nums. And what is our answer? This is our answer, correct? So what would be the time complexity for this solution? The time complexity for this solution would be order of n log n plus order of n, correct? Which would be eventually order of n log n only. Let's see how. So this order of n log n is for sorting the nums array, correct? And this order of n is for traversing over this nums array using the two pointers P1 and P2 in order to find out that which are the two numbers that are occurring twice, correct? So our final time complexity would be order of n log n. And what is the space complexity? The space complexity is order of 1 because we are not using any extra space from our end, okay? So we made sure that we are not using any extra space complexity. Now the question is, are we going to use this solution in order to solve this problem? The answer is no. Let's see why. So in the problem, we can see that can we write an algorithm that runs in order of n time complexity? So what does it mean? It means that we should have a time complexity of order of n, but here we are having a time complexity of order of n log n, correct? So let's see, can we have a solution of order of n that doesn't uses any extra space? So initially, this is our answer vector, which is initially empty, and we have the elements of nums over here, and these values represent the indices, okay? So what we will do is we will iterate over nums, and what is the value we are getting over here? It's 4, right? So what we will do is we will set the element which is present at 4 minus 1 index, correct? So what is 4 minus 1? 4 minus 1 is 3. So what we'll do is we will set the value present at this third index to the negative of it. So since we have 7 over here, so what we'll do, we'll set this 7 as minus 7, correct? Now, why are we doing this? So we know that there are some numbers that are occurring twice, correct? So let's say if we are over here, right? That is if we are at this 2. So for this 2, what we will do is for the index 2 minus 1, we will set its value as negative. So what is 2 minus 1? It's 1. So what we'll do is we will set the value present at the 1th index as negative, correct? So let us consider this 2 again. So when we'll get this 2, what we'll do is we'll set the value at this 2 minus 1th index as negative. So since this value at 1 index is already negative, so what it would be? It would be positive now. So what we will do is we will iterate over nums, and set nums of, let's represent this I as index minus 1 as nums of index minus 1 negative, correct? So what are we doing is we are setting this to a negative number. And why are we doing this? That after doing this, what we'll do is we will check that if this nums of I minus 1, if this is greater than 0, then what does it mean? It means that the element present at this index, that is this 2, is repeating itself. Why? Because if this 2 wasn't repeating itself, then what would have happened? In that case, this 3 would remain negative only, correct? But this 3 is turning into positive. Then what does it mean? It means that this 1 plus element, that is this 2 element, is occurring twice. Then only this 3 is getting turned to a positive number again, correct? Because if this 1 plus 1, that is if this 2 wasn't repeating, then this 3 wouldn't have been 1. It would have remained negative only, correct? So that's the reason why we are iterating over the elements of this nums. And what we are doing is, let's say the current element is current. So what we are doing is we are setting the value present at this current minus 1th index to its negative. Now you'll ask that why are we doing this minus 1? So we can clearly see that we have integer from the range of 1 to n. That is, here we can see that we have 8. But do we have nums of 8? So we don't have nums of 8, right? So for that reason, we are doing in the value minus 1. So if we'll get 8, then we can't set nums of 8 as negative, right? Because nums of 8 doesn't exist. So what are we doing? We are setting nums of 8 minus 1. That is, we are setting nums of 7 as negative. Correct. So let's do a quick dry run in order to understand this in a better way. So what we have to do, we have to initially iterate over nums to set this. Correct. So currently we are at this element, that is at 4. So what we will do, we will set the value present at 4 minus 1, right? So what is 4 minus 1? 4 minus 1 is 3. So we will turn the element present at the third index to negative. So we have 7. So what we will get? We will get minus 7 over here. Correct? Now we will move forward. So what is the value we are getting over here? We are getting 3. So what we will do? We will turn the element present at 3 minus 1 index to negative. So what is 3 minus 1? 3 minus 1 is 2. So what we will do? We will turn the element present at the second index to negative. So this 2 will become minus 2. Correct? Now we will move forward. Now, what is the value present at the second index? The value present at the second index is minus 2. But does minus 2 index exist? No. So before doing this, what we have to do, we have to also add abs in order to make it positive. Correct? Because there is a possibility that the element in our nums is negative. Correct? So if we will set that minus 2 minus 1, so what it would be? It would be minus 3, and index as minus 3 doesn't exist, right? So here, what is the value? The value is 2. Correct? So what we will do is we will set the value of the index at 2 minus 1 as negative. So what is 2 minus 1? It's 1. So we will set the element present at this 1th element as negative. So what we'll get? We'll get a minus 3 over here. Now we will move forward. Now what is the element present over here? That is, we are ignoring the sign as of now. So what is the element present over here? It's 7. So what we will do? We will turn the value present at 7 minus 1th index to negative. So what is 7 minus 1? It's 6. So it means that we are going to turn this 3 to negative. Correct. Now what we will do, we'll move forward. So what do we have over here? We have an 8. So what we will do, we'll turn the element present at 8 minus 1th index to negative. So what is 8 minus 1? It's 7. That is, we are going to turn this one to a negative integer. Fine. Now we'll again move forward. Now what do we have over here? We have a 2. So it means that we are going to turn the element present at 2 minus 1th index to negative. What is 2 minus 1? It's nothing but 1. So we are going to turn the element present at this 1th index to negative. Now we are going to check that if this number is greater than 0. So is this greater than 0? So we can clearly see that this 3 is greater than 0. Correct. So what does it mean? It means that this particular element, that is this 2, has been repeating itself. Why? It's because of this 2 only we set this 3 to a negative number and then back to positive number. Let's see how. So when we were present at this 2, we turned this 3 to minus 3. And when we reached to this 2, what we did, we turned that minus 3 to positive 3. So it means that this 2 is repeating itself, because if it wasn't repeating itself, then this 3 would not have been converted to a positive integer. Correct. So what we will do, we'll simply say that answer dot pushback nums of I. That's all. And before that, we also have to add an abs, because there might be a possibility that it's negative. And here as well, we have to add abs. Correct. So what are we going to do? We are going to push this 2 in our answer, representing that it's occurring twice. Okay. Now we'll move forward. So we'll reach to this 3. So what we'll do, we will set the element present at 3 minus 1th index to negative. So what is 3 minus 1? It's 2, right? So we have 2 index over here. So what do we have over here? We already have minus 2. So what we'll do, we'll set its sign to positive. Now we can see that the value present at this point is positive number. So what does it indicate? It indicates that this 3 is repeating itself, because we can clearly see that using this 3, we turned this 2 into a negative number, and using this 3, we turned it back to a positive number. So it indicates that this 3 is occurring twice. So what we'll do, we will simply add this 3 back to our answer. Correct? Now we'll move forward. Now what is the value? It's 1. So what we'll do, we'll set the value present at 1 minus 1th index to negative integer. So what is 1 minus 1? It's nothing but 0. So what we'll do, we'll turn the element present over here to negative. Correct? So we get a minus 4 over here. Now what we'll do, we'll move forward. Now we can clearly see that we have processed all the elements of nums, and this is our answer. Correct? So I hope the solution is clear to you all. So let's quickly code this. So let's create an answer vector After that, what we have to do? After that, we have to iterate over nums and set the value like this, correct? So let's do it. So what we'll do is we'll say for index equals to 0, index less than nums dot size, index plus plus. What we have to do? We have to set nums of index minus 1. Now there is a possibility that this nums of index could be negative. That's why we are going to take only its positive part, correct? So we are going to set this value as the negative of this value, that is as the negative of nums of index minus 1, okay? And this would be by only considering the value, not the sign, correct? Now at any moment, if we get that this value is positive, then what does it mean? So if we get this value is greater than 0, correct? So in that case, what does it mean? It means that the value present at this nums of index is repeating itself, correct? It's occurring twice, then only this particular number could be positive, right? So what we'll do, we'll simply say answer dot pushback nums of index, correct? And after that, what we'll do, we'll simply return this answer. So now let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So the time complexity is order of n. Why? It's because we can clearly see that we are simply iterating over all the n elements of the array over here, right? So it means that it is costing us a time complexity of order of n. And we are not using any extra space from our end. Therefore, the space complexity is order of 1. Additionally, let me mention that this answer is not counted as an extra space because we are supposed to return it, right? So that's all about today's daily LeetCode challenge. Thank you.